Hello everyone, and welcome to part 1 of this series on applied physics and archery stabilization. If you spend any time around competitive archery, you'll hear a lot of conversations about stabilizers. People talk about bar lengths, they talk about weight, they talk about ratios. You'll hear things like run more front weight or add more back weight. And if you ask enough people, you'll probably get a dozen completely different answers. But the strange thing is that very few of these conversations actually talk about the physics that govern what stabilizers are doing. Most of the time, people are just describing setups that work for them. But without understanding the physics behind it, those setups are very hard to reproduce or adjust. So in this series, we're going to take a step back and look at stabilization from the perspective of applied physics. And from the first thing we need to do is clear up the biggest misconception in stabilization. Most archers believe that the goal is to hold perfectly still, but that's not actually the goal. The goal of stabilization is not to eliminate movement. The goal is to control movement. Those are two very different things. A human being is never going to be perfectly still. Your muscles are producing force. Your nervous system is constantly making corrections. Your body is alive, which means some amount of movement is inevitable. So the real question is not, how do I make the bow stop moving? The real question is, how do I make the bow move in a way that is slow, predictable, and easy to control? Because when the sight picture moves slowly and predictably, the shot can run naturally. But when the sight picture moves quickly or erratically, the archer starts interfering with the shot. Now here's where the physics comes in. A bow is not just something you hold. A bow is actually a rotating mechanical system. The bow rotates around the grip. And when you aim the bow, it can rotate in 3 basic ways. It can move up and down, your pitch axis. It can move left and right, your yaw axis, or it can roll to the side, your roll axis. Those are the 3 axes of rotation. And the entire job of a stabilizer system is simply this: resist unwanted rotation around those axes. That's it. Not balancing the bow, not making the bow heavy, resisting rotation. That's it. Once you understand that idea, stabilizers start making a lot more sense. Because now we can ask 2 very simple physics questions. What causes the bow to rotate, and what resists that rotation? The answer to the first question is torque. The answer to the second question is inertia. Everything in stabilization is just the interaction between those 2 forces. Torque tries to move the bow. Inertia resists that movement. If torque is large and inertia is small, the bow moves quickly. If inertia is large relative to torque, the bow moves slowly. And slower movement is exactly what we want in an aiming system, because slower movement produces a sight picture that is easier to read and easier to execute from. So in the next video, we're going to talk about torque, because torque is the force that actually tries to rotate the bow. And once you understand torque, you'll start seeing examples of it everywhere in the real world.